Welcome back to the video. Today we're going to do another Turing machine example. So we're going to do it for this language. A to the I, B to the J, C to the K, I, J, and K are all greater than 0, and then I plus K equals J. And this is how we're going to read, write, and this is how we're going to move. This is going to be like the way we're going to like traverse like the tape or whatever. The first symbol we're going to read, and then the second symbol we're going to replace it with something, so write, and this is the direction we're going to move. And the first thing I like to do, I like to actually like write the string out. And I'm going to give some values I, K, and J. So we can say I equals 2. I'm looking at this part right here. K equals 3, sloppy 3. And therefore J equals 5 because 2 plus 3 is 5. A corresponds to I's. I'm looking at right there. A to the I. In this case it'd be A to the 2. So it's going to be 2 A's. Next is B. B to the J. So it's going to be 5 B's because J equals 5. And then C to the K. K equals 3. So it's going to be 3 C's. Normally when I have a string, I like to find a pattern for the string. So I just start canceling out 1 to 1. So we're going to read an A, cross off a B. Read an A, cross off a B. And then I see there's 3 B's left and then 3 C's left. So we could cross off a B for a C, B for a C, and B for a C. And in this case, there's no remainders. So that would work for this one. Let's change up the numbers. Let's do 1, 1, 2. So there's going to be 1 A, 2 B's, and then 1 C. So we're going to cross off an A for a B. Once there's no more A's, we can cross off B's for C's. So in that case, that works. So that might be our algorithm. Let's try a bigger number. We'll do 4, 2, and 6. Because I is 4, K is 2, so therefore J is going to be 4 plus 2 is 6. 4 A's, J corresponds to B, so 6 B's. And then K corresponds to C, so 2 C's. For every A, read a B, read a B, read a B, A, and B. And we see there's 2 B's left and 2 C's. So B to C, B to C. And that looks like that's our algorithm. So let's actually write it down. We could say, I'll just call it algo description. For every A, match to B. And then out of A's, so when we're out of A's, then we could say match B's to C's. And then nothing left over, we go to accept state. Nothing left, accept state. So in my past videos, I've been kind of writing the algorithm, but I actually want to just write the Turing machine. Let's see how that goes. So we're going to start at Q0. Let me have an example of the string. We could say, I'll write it down here. I equals 2, what's next? I plus K. We say K equals 3, and then J has to equal 5. So we have 2 A's because A to the I. B to the J, so that's 5 B's. 1, 2, 3, 4, 5. And then 3 C's. So for every A, we're going to match a B. Once we're out of A's, we're going to move over and match the B's to the C's. Okay, so let's start doing that for the first case, which would be the A's. So read an A, write an X, move to the right. Let me get rid of this. So we just have our string. First step, we're going to read an A, write an X, move to the right. Head is right there. Now we're state Q1. So now we want to like get past all the A's. Well, we could do that. We could self loop. Write an A, read an A, move to the right. But what if there's a Y right here next time we iterate through the string? So we'll future proof it by writing a Y. So we're going to read all A's and all Y's. And then once we hit a B, we're going to read the B, write a Y, and then move to the left. So all the A's, in this case there's no Y's right now, but there will be. We're right here. We're going to replace this B with the Y, and then move to the left. Okay. And now we can have another state right here. This is going to be Q2. At Q2, we want to go all the way back until we hit an X. So we could read all the A's again. Read an A, write an A. But in this case, we're going to go to the left because we want to keep going until we hit an X. Same with the Y's. Read a Y, write a Y, and then move to the left. Imagine our head was right here. So we would pass Y's and A's on the way to an X, but our head is actually right here. Once we hit an X, make this a little neater. Once we hit an X, we're going to go back. Read an X, write an X, move to the right. Because we kind of want to start the loop over again. So now we're right here again. Now we're above the X, but we wanted to move to the right. So now we're sitting above an A. So we're going to read an A, looking at Q0, between Q0 and Q1. Read an A, write an X, move to the right. Right here, we're going to bypass all the A's and Y's. In this case, there's only one Y until we hit a B. Once we hit a B, we're going to write a Y and then move to the left. So now we're right here. We're going to bypass all the A's and the Y's until we hit an X. So we're going to go back to the left until we hit an X. In this case, we hit an X right here. So this is where we're at. But we're going to move to the Y. We're going to move to the right. But once we move to the right, it's saying we have to read an A, which we can't do that because we haven't written that out. I mean, we have, but all the A's are gone. So that means we have to do some different states. So we actually did the first part already. For every A, we wrote a B. Now we have to go to like a different, almost like a different loop. For every B, we're gonna write a C. So once we're out of A's, we're not gonna once we're right here, once we're out of A's, we're not gonna see an A next to the right of the X. What we're gonna see is Y's. To the right of the X is gonna be a Y. So we could write that. Read a Y, write a Y, and then move to the right. So now we're right here. But we could also self loop all the Y's. We could do read a Y, write a Y, move to the right. We want to self loop all the Y's because we want to get to a B. Because remember, we want to match B's to C's. What state of this is going to be Q3. Once we get to Q3, we're looking for a B. So you can say read a B, write a Y, move to the right. So now we're right here. We're going to replace this with the Y and then move to the right. Now we're looking for a C because remember, once A's match to B's, we're out of A's. We're going to match B's to C's. We already wrote a Y for the B. Now we have to go until we hit a C. So now we're going to be right here. And now we could bypass all, in this case it would just be B's. And remember in the future there might be a Z here, so we got to future proof it. So we could say read a B, write a B, and then we're going to move to the right. Read a Z, write a Z, and then move to the right. And we're going to keep doing this until we find a C. We're going to read a C, write a Z, and then move left. So we're going to bypass all the B's until we hit a C. Now we're right here, we're going to replace it with the Z, and we're going to move to the left. And then we're at this state now, which is going to be Q5. And now we want to bypass everything again until we hit a Y. Kind of like we did here. We're going to bypass everything. This is pretty much the same thing as that. We're going to bypass everything until we hit a Y. So the way we could do that, what are we going to see on the way back? We're going to see Z's and B's. So we could read a B, write a B, move to the left, read a Z, write a Z, move to the left. You don't see it here, but imagine that the head was right here. We would see Z's and B's on the way to the Y. In this case, we're sitting above this B. But in the future, that's what we're going to see. And then once we do that, like in the other example, we're going to read an X, write an X, move to the right. But in this case, we're going to read a Y, write a Y, move to the right. We'll do it right here. Read a Y, write a Y, move to the right. So now we're right here above this B. Because whenever we see a Y, to the right of it should be a B if there's still B's left. Once we get that, we'll get to, we'll call this another state. We'll call this Q6. A little neater. Once we get to Q6, we're going to send it back to Q4. But to Q4, we're going to read a B, write a Y, and then we're going to move that to the right. So we're going to be right here, and then we're right there. And then we're back to our loop. We want to keep looping until we get a C. So all the B's, we're going to pass this B, and then remember how I said we want to future proof it for a Z. There's a Z we were talking about until we hit a C. Once we hit a C, we're at this step. We're going to write a C, read a C, write a Z, and then we're going to move to the left. So now we're sitting right here. Now we're going to go all the way to the left until we hit a Y. In this case, we're going to bypass a Z and a B. That's why we future-proofed it once again until we hit a Y. So now we're right here. Once we hit a Y, we're going to move to the right. We're going to read the Y, read the Y, write the Y, move to the right. So now we're above this B. Once we hit above that B, we're at this state. We're going to replace the B with the Y, and then we're going to move to the right. So our arrow is right here. Now we're above a Z. So now we're going to bypass B's and Z's. Oh, did I not write I think I skipped the read a C, write a Z, and then move to the left. I can't believe I didn't write that. I had it in my head. Read a C, write a Z, move to the left. So I had it in my head, but I never wrote it out. So now we're right here. We're at state Q4. We're going to bypass all the B's and the Z's until we hit a C. So now we're right there. Now we're at this state. Now we're going to replace that with the Z. Oops, let me not erase that. My mistake for not writing that. And then we're going to, let me see. So we're right here. We're pretty much at the end right now. From the end, if we get a blank, if there's nothing to the right of it, that means it gets accepted. So if we read a blank, that just means blank. Write a blank, and then move to the right. And then from there we go accept state. Because there's nothing more to be read, so we're pretty much done. So that's all it is. But now we have to worry about the edge cases. Like, what if could the string equal 0? Yeah, I plus k equals j. So we could have 0k, 0 i's plus 0 k's equals 0. So that means an empty string from q0 can go to accept. Let me see if I can move the little Turing machine to the right so I can actually write it. When I say empty string is in the language or whatever, that means nothing could be entered and it should still be accepted. So we do blank, write a blank, and then move to the right. So that's going to be accepted. Let's say, what if I equals 0? I would say I equals 0, k equals 1, and that would have made j equal to 1. So 0 a's, so and then 1b and then 1c. Okay, let's see where would we be at. So from this one, we're going to have to skip a state. We can go from Q0 to Q4. We could read a B, write a Y, and then we'll move that to the right. So we're going to read a B, write a Y, and then move to the right. Now we're above a C. Once we read a C, we could write a Z over it. Now we're right here. We'll write a Z over it, and then move to the left. So now we're above the B. And then what we could do, we could bypass all the B's or Z's. So there's a Z above here. So now we're right here. And then if we go over to if there's nothing to the right, that means it's blank. That means it gets accepted. So that case is accounted for. What other case? We did what if I equals 1 and then k equals 0 and j would still be 1. So it'd be 1a, k corresponds to C's, so it'll just be AB. So let's see if we have that accounted for. So we're writing an A, and we're looking right here. See if we have to add any states or if it's already accounted for. Okay, so we're right here. See, we have an A, write an X, move to the right. So I'm going to write an X, move to the right. We're right here. Bypass all the A's and Y's. We already have the B. We're going to write the Y, move to the left. And then from there, we're going to move to keep looping until we see an X. Once we see an X, we're going to move to the right. So now we're right here. Let me see, does that get accepted? So now we're at Q3, and there's nothing to the right of it, so we could actually kind of go around. Once we get to Q3, if there's nothing to the right of it, we could just say blank, write a blank, and then move to the right, and that should accept AB. So let's retry it again. Okay, so we're at Q0, read an A, write an X, move to the right, hit us right here. In this case, we don't have to bypass anything because the B is next. So we're going to read a B, write a Y, move to the left. Y, move to the left. And then we don't have to bypass anything here because we're sitting above an X already. So we're going to read an X, write an X, move to the right. So now we're at the B. Okay. So now, no, we're above a Y right now. Read a Y, write a Y, move to the right. So now we're sitting above a blank. So that works. If we see a blank, write a blank, move to the right, and then we go to accept state. And then I think those are all the edge cases that I could think of. So this is pretty much the Turing machine right here. I may have missed something because I'm just going off the top of my head. But if this helped in any way, please leave a like and subscribe.